So let's try this again. So problem number 1. If you worked it out correctly, you would have ended up with 2 plus root 3 at the end. If you didn't get that, check your work. My advice to you, and I've seen a lot of people kind of skip this advice, when you get to this stage, before you start multiplying by your complex conjugate, get rid of your fraction. Make that a lot easier to deal with, because I don't want to multiply top and bottom by 1 plus root 3 over 3. That's just a lot of work. And you're going to eventually have to deal with that fraction anyway. So why not knock it out first thing? David had a little chest pounding moment. Okay, here is number 2. Should have been positive. This square root is over both of those numbers. So square root of 2 minus the root 2, all over 2. The square root is not over the 2 in the denominator. 2's everywhere. And I still can't plug it in. You needed to notice that 157.5 starts off in quadrant 2. Yes, sir.
Why is it positive?
It's positive because 157.5 starts off in quadrant 2, and sign is positive in quadrant 2. Okay? That's where you make your decision, not this one. Okie finokie. 3 really should have been very quick. When you see something as nasty as that, try to go, oh, there's no way that she's going to ask me to do that, and say, can I find a formula where it is sine, cosine, minus, cosine, sine? Sine, cosine, and there's my minus. So that's the formula that we're using. Another reason why it's nice to have all of your formulas in one location and your unit circle there also just makes life go a little bit easier. And then number 4, there's all sorts of different ways that you could have worked this. The keys were understanding that tangent is sine over cosine, so changed both those tangents, and the fact that the sine of alpha plus beta, that formula expands out to this. And then how you chose to go about that, whether you chose to distribute and have this as the next line, and then this, it's just as long as you eventually have left equals right. That's all I really care about. Okay. So I actually usually would have gone from here to here and then to here and had left equals the right. So it's just all sorts of different ways that you can flow with that. Go with the flow. All right, so you guys, again, you got your tests back. Your corrections are going to be due Monday. I think it's very important that you guys do that by Monday, simply because those same formulas, those same things are all going to pop up on our quest that wraps up this entire trig stuff. So you want to make sure you keep that fresh in your head. Okay? You will have those formulas just like you had for the test on the next quest and on the midterm as well. Okay? Not on the quest. The quest, it's just that when we go through, and you'll see it today, there'll be times when we have to use the sum and difference or the double and half angle formulas in order to solve. So that's why you'll have that available to you. Okay. So today is really a combination of trig and algebra. And kind of, sort of, algebra. Algebrig. I kind of like algebraic. I think that's kind of fun. And what it is we're going to be using all that we know about trig to solve equations. But the basic idea behind solving equations, well, it's those same old rules that you had in Algebra 1 and Algebra 2. We're still following the order of operations and working it out. And to me, the absolute greatest part of math is the fact that you can actually check your answers. To this day, I will always be traumatized by the fact that in English, the teacher graded my interpretation of the green light at the end of the pier in The Great Gatsby as incorrect. It's a freaking interpretation. should be up for discussion. Math's not up for discussion. You should be able to tell without a doubt if you got it right in the end. Yay, math. Math's beautiful. I don't hold that a grudge at all. You're the wrong interpretation. Yeah, that really... It's an interpretation. How could it be wrong? There you go. There you go. See? We're special. Okay, so if I wanted to check to see, for example, that pi over 4 was a solution. Let's say I went through all of this and I got pi over 4 as my answer. How can I check to see if I did that right? I know it's... How do you normally check an answer? Plug it in. So if I want to know if this is a solution, I can simply plug it in. 2 times the sine of pi over 4 plus root 2. I want to know if that's equal to 0. What is the sine of pi over 4? Root 2 over 2. And I have that times 2. And you might be able to tell just by looking at it now that that's not going to be true. But what is 2 times root 2 over 2? Root 2. So that leaves me with 2 root 2. That is not 0 the last time that I checked. So is it a solution? No, those are not equal. It is not a solution. Gotta love it. You can do that in math. You can't do that in every single subject. I wish you could. I can do the same thing with another answer. 5 pi over 4 instead this time. So I will have 2 times the sine of 5 pi over 4 plus root 2 equals 0. Now this is still a pi over 4. And for all of my pi over 4s, the signs are always the same. The signs are always at root 2 over 2. But what changes for this guy? Yeah, this one's going to be negative. Because 5 pi over 4 is in which quadrant? Yeah, it is in quadrant 3. And in quadrant 3, sign is negative. Now that I have that, this becomes negative root 2 plus root 2. What does that give me? Yeah, and what's negative root 2 plus root 2? 0. And since 0 is equal to 0, I can tell that it's a solution. So it's really important to notice that even though we're talking here about trig, all of those rules from algebra still hold place. You can still check. You can still make sure that your answers work. The place where trig gets a little bit different is in this word here. A trig trig deals with circles. Circles are like making angles. And the thing is I can spin around a circle as many times as I darn well want until I'm puking everywhere. Isn't that a lovely mental image? No? Not so pretty? And so what happens when we solve trig equations, we can actually have an infinite number of solutions, but we have to figure out how am I going to write that. So go ahead and write down number 2. And we have done number 2 before, but we haven't talked about it in this sense. We really love those root 2's over 2's because no matter what, sine or cosine, what angle are you talking about with that? A pi over 4. One of my pi over 4's. Okay? And if I'm talking about my pi over 4, where is it going to be negative? Quadrants 2 and, one more time, 3. So in quadrant 2, what angle is that? Three pi over 4. And in quadrant 3, 5 pi over 4. Now the thing is, what makes this a little bit tricky, these are the answers that lie between 0 and 2 pi. Those are just the answers that lie within the first circle that we would make. But I could, instead of just going like this and having 3 pi over 4, I could go all the way around and back to that. What is the difference between this initial angle and the one where I spun all the way around? Well, it's not plus 360 because we're talking here in terms of radians. I've added 2 pi to that. And the way that we've represented the fact that I've added 2 pi, and in fact I can add 2 pi as many times that I want, we say plus 2 pi k, and we say that k is an integer. Saying k is an integer just means they're full circles. Every time I do a 2 pi, that's why I'm not going to have 2 pi 1/2. I'm not going to do half a circle. I'm only doing full circles. And the same thing is true about this angle, the 5 pi over 4. I could go to here. That's my 5 pi over 4. Or I could go this way even. How would I get to that direction? How do I go back this way? Negative. And so what I'm trying to get you guys to see here, integers can be positive or negative. So technically that can be pluses or minuses. But we write this still as plus 2 pi k, and in both cases, k is an integer. As long as you write that k is an integer once for each problem, I'm okay. But just writing in big letters across the top, k is an integer, is not good. You got to do it for each problem. So if we're talking about just the 0 to 2 pi solutions, it's pretty straightforward. It's what we've always done. But when we're talking about all solutions, you have to understand that no matter how many times I spin around a circle, if I end in this spot, the cosine will always be the same. So that's why I can add circles to it. Okay? So let's think now about the tangent. And please, ladies and gentlemen, don't say, ooh, I know tangent is sine over cosine. Don't do that. This is a lot easier than that. Okay? Tangent is what over what? Y over x. So if tangent is y over x, we're looking for the coordinates where it's 1 and root 3. So that's the point that we're looking for. Now that tangent is positive in which quadrants? 1 and 3. So I'm going to have this angle, and I'm going to have this angle. In quadrant 1, what angle is that? Pi over 3? You guys okay with that? And if you have kind of forgotten, and you don't have your unit circle, just to take a second to remind you how easy this is to build. If you think of the first quadrant, it should be quite simple. What is this coordinate right here? That's the angle. What's the coordinate? 1, 0. Over 1, up 0. Where this is over nothing, up 1. I know for a fact, because this one's easy, the root 2 over 2 is always in the middle. And I gave you a little hint. So that if you start from 1, you can think about it as root 4, root 3, root 2, root 1, 0. All over 2. And then the other way works the same. So remember that trick is always there for you. And in terms of radians, what is this guy? Pi over 6, pi over 4, pi over 3, and pi over 2. Obviously 0. Or in terms of degrees, what's this? 30. Okay. All right, so if you have forgotten your unit circle, just remember how simple it is to construct the first quadrant. And once you get the first quadrant, everything else should come pretty quick off of that. So again, which coordinate was this? Pi over 3. And what coordinate was this? Pi over, I know it's going to be an over 3. That's going to be 4 pi over 3. So I would write all solutions as being pi over 3 plus 2 pi k, 4 pi over 3 plus 2 pi k, where k is an integer. But, and this is an answer. This answer, like if this was a 10-point question, this answer would get you probably 8. But there's a reason why this wouldn't get you all of the points. Our goal in math is for really lazy people, believe it or not. I don't want to write 2 answers if I can write 1. Which is why I'm not going to sit here and write 3 pi over 4 plus 2 pi, that's going to give me 11 pi over 4. And then 19 pi over 4. I'm not going to write them out. I wrote it this way. There is a way to make this shorter. It does not work over here, but it does work over here. I know the adding 2 pi k will always work. What we can do is we can check, is there something smaller that I can add? Yes. If I add pi k, because if I'm adding pi is the same thing as saying what pi over 3. If I wanted that in terms of over 3. Pi over 3 plus what gives me 4 pi over 3? Do you see what I'm talking about there? To go from here to here is 3 pi over 3. What's 3 pi over 3? Pi. So this is adding pi. If I added pi again, do I come back to my line? So I actually am going to condense those into pi over 3 plus pi k. And this is the answer, where k is an integer. Yep, and the reason why you have to for the first one is to get from 3 pi over 4 to 5 pi over 4, what would you have to add? 2 pi over 4, or 1/2. And if I added another half, does that angle work? No. So that's why this one had to be written as 2 separate equations, but this one can be written as 1. Mm-hmm. Okay? Yes? Yes, per problem. Because sometimes people use different letters, sometimes k might be a variable. So we typically use k and we have to state it's an integer. Okay? Yes? Yes, that would be marked. You'd lose a point for that. You can't just put the double z in there, which is the integer sign. Do you understand? Okay. All right. Now all we're going to do is I'm going to increase the difficulty of algebra. The trig doesn't change. The trig is the same. And all you need to think is that this guy here is my variable. Go ahead and write that down. I get so excited, I just want to go. Let's do math. Yeah. If this had been algebra and that was just an x, how would I solve for that? What would you do first? So you would subtract 2. So that's what I'm going to do. And then you would divide by 2. So we're looking at where is the cosine of x -1. Do you see how simple that is? Don't let basic algebra throw you off. Okay, now this one, look to see what this says up here. This says solve the equations from 0 to 2 pi. Do you notice how this has an equal to under it and this doesn't? It means you can have 0, but you can't have 2 pi. And this also tells me that my answers have to be in radians. If I see 0 to 360, what do you think my answers have to be in? Degrees. Okay, so let's think about this. Cosine is which coordinate? The x. X is -1 right there. What is that angle? Are there any other angles that give you a cosine of -1? Not that are within just that one circle. So you can have one angle. You can have a whole bunch of solutions. It's not always going to be 2. It's not always going to be 1. Sometimes you'll have 4. Sometimes you'll have even more than that. I'll show you when that occurs. Okay? So why don't you guys see if you can do number 5 on your own? So let's take a look at the answer here. And really, when it comes down to work, because all that was basic algebra, add 3, divide by 2, I just need to see this piece here. Okay, so I guess that didn't hold my coat. I tried. Because again, the answer here is just from 0 to 2 pi. So when you have what's called a limited domain, you don't do that end piece. If you see the words, like we had on the previous problem, all solutions, that's when you do the 2 pi k. Thaddeus. Nah, just really the answers is okay. I'm not going to take off if you don't write theta equals. Was that what you were going to ask, Craig? Okay. All right. So that's the gist of what we're talking about here, the main kind of coverall. And that's the fact that our algebra rules still apply and how to handle when we have trig. But we know from algebra, this is like algebra 1 solving equations. Algebra 2 things got a little bit trickier, didn't they? And so we have a situation like that for problem number 6. And actually, 6, 7, and 8 are along the lines of what you can expect to see. Go ahead and write down problem number 6 for me. Don't let this freak you out. Basically, what this is saying here is that those guys are the same. I can solve this problem the same way I would solve x squared minus 2x plus 1 equals 0. If you have a variable squared and the variable not squared at the same time in the same problem, what do you have to do in order to solve? Factor. You absolutely have to factor this. And if I were to factor this, I would factor this out to be what? No, just kind of, let's be basic, let's be babies. We would have x minus 1, x minus 1. And with factoring, the solution to this uses the zero product property. If two things multiply to equal 0, then that means that either this equals 0 or this equals 0. Well, hey, they're the same thing, so yay life. And if I were to solve that, I would have x equals what? 1. But it wasn't x in the original problem, was it? It was cosine of x. Mind blown. Okay, so now I'm talking about from 0 to 360. Means I'm still just in my one circle. Cosine is which coordinate, the x or the y? That is the x, and x is 1 right here. What am I going to say that that value is? 0 degrees. We are not going to say 360. 0 is included, 360 is not. Looking at number 7, go ahead and write that guy down. I hear some pages flipping, and I think that's a good thing because it tells me, what do you think they're doing? Looking for some double angle formulas, because there are quite a few problems going on in this. My first thing that I see is that I have cosine and sine. That worries me a little bit. Cosine and sine. How am I going to do that? Well, I'm not going to really rewrite cosine, so that is going to stay the same. But the sine of 2x, if I look at my double angle formula for sine, do you see that here? That is 2 sine x cosine x. Now, I don't have any squares here, do I? So I cannot rewrite cosine into sine or sine into cosine. This is where I'm at. So what we're going to do is we are going to have to somehow factor this. But before I factor, what do you think I want this equal to? 0. So that's 2 sine x cosine x. It really doesn't matter which side you move it to. I just chose to move the smaller one. And I can still solve this problem. Yes, sir? Right. Because this isn't a verifying identity. This is an actual solve. A solve, you have to start with the idea that they're equal. Verify, we're trying to get that idea that it's equal. Good question. Any idea of what I would do here? Take out cosine, because this is like saying 2xy minus x. If I had that in x's and y's, because those are two different things. So what we do with this is we simply factor out the greatest common factor, which is the cosine x. And when I take out cosine x, I will have 2 times the sine of x minus 1. Again, we're going to use the zero product property. That means I get the cosine of x equals 0. And when I set this equal to 0, you will add 1 and divide by 2. Do you understand what I'm talking about there? To solve that? So I would have the sine of x is 1/2. Do you understand what I did? If I have 2 times the sine of x minus 1 equals 0, to get the x by itself, I would add 1 and then I would divide by 2. That means I'm going to think about this as 2 separate problems. I'm just going to put all the answers together when I'm done. Cosine of x is 0 where? Because that's going to be 0. That means it's up here and down here, right? You okay with that? That's when x is 0. No. We don't, and technically x is 0 there, but everything that we're doing is on the unit circle, so it's a solution to x squared plus y squared equals 1. Okay? So that means what angles do I have? Careful, careful, careful. 90 degrees and 270 degrees. Why am I doing degrees? Because it says between 0 and 360. Then for the sine is 1/2, sine is going to be positive in which quadrants? 1 and 2. And which angle has a sine of 1/2? Pi over 6, which is 30 degrees. So this is 30 degrees, and if you remember how this works, if I back up, this is 180, minus 130 gives me 150. Those are your answers. Can you just kind of stop for a moment, think back? If I had given you a problem like that on the first day of school this year, this semester, this semester, would that have just blown your mind? Look at how far you guys have come. Sure, you might still need help with this, but hopefully as we work through it, you understood what we were doing. Sometimes you need to be reminded of how far you've come. Okay? All right, let's take a look at number 8. Similar to number 7, I'm starting off with a cosine and a sine, and I'm starting off with a double angle, but where's my double angle this time? Cosine. So if I look at my cosine formula for double angle, that's cosine squared minus sine squared. So rewriting that out gives me cosine squared minus sine squared. And here we hit a couple of problems. I have squares and not squares. I have sines and I have cosines. Now, you can either deal with one of those or the other. I can either have squares and not squares, but they're all the same trig, or I can have different trigs, but they're all the same. So I have to change something. Can I change this to be written in terms of a square? You can't, because that's just sine. Can I change this to be written in terms of sine? Yes, that we can do. What is cosine squared of x? 1 minus sine squared x. And if I combine this, minus sine squared and minus sine squared is if you have a problem that has squared and not squared in it, what do I have to do in order to solve it? But in order to factor, before I can even do that, I have to get it equal to 0. So I'm going to move these things over here because I like my squares to be positive. That way I will have 0 equals, it'll be 2 sine squared x plus sine x. And when I subtract the 1, that one will cancel out. I subtracted 1 and I added 2 sine squared x. How do I solve this? What did we do? We factor. It's only 2 pieces, that's okay. How do I factor that? Pull out a sine x. So this is sine x times 2 sine x plus 1 which tells me that the sine of x is 0. And what would I get from this one? Sine of x is negative 1/2. So sine is 0 where? At 0. And thank you for saying 180. Making sure we're putting our degree symbols. Sine is negative in which quadrants? 3 and 4. So, which angles are those going to be? If it had been an angle 1, where's the sine 1/2? The sine is 1/2 at 30. 30. Pi over 6 is 30 degrees. So if I were to go 180 plus 30, where would that take me? 210. And if I were to take 360 minus 30, 330. Here's your answer. Okay. I'm going to do one more with you guys, 2 more maybe. Just because of the way you have to think these through and all the options that you have. Okay, ready? Oh, you're not packing up. I was like, what are you packing up for? Getting more paper. Killing trees. Gotta love it. All right, go ahead and write down problem number 9. Now, the interesting thing about number 9, we've dealt with what happens when we have a double angle. And when I go through this, I tend to get on a train. Okay, so I used a double angle formula before. I'm going to use a double angle this time, and I'm going to work it out. And it does work. It's just a heck of a lot harder than it needs to be. The reason why I say that, do you see how the only trig ratio I have in this whole equation is cosine of 2 theta? If I wanted to get just that by itself, I would have the cosine of 2 theta is equal to what? 1/2. This is what I consider to be the easy way to do this. Cosine 2 theta is 1/2. If I were to think about my unit circle, and you see over here how it says 0 to 2 pi? That tells me my answers need to be in terms of radians. What quadrants have a positive cosine? 1 and 4. In quadrant 1, what is your angle? What's your angle? Pi over 3. Oh, it is pi over 3, yeah. 2 theta is pi over 3. In quadrant 4, what do you get? 5 pi over 3. Now this is a little bit weird. We have to, instead of doing this one first and saying, oh, my answers are pi over 3 and 5 pi over 3, those, when I solve this, will have something to do with my answer, but that's not it. We've got to be real careful. So what we're going to do is we're going to pretend that we're doing the all solutions first. You see what I just did there? Okay. Now, if I wanted to get the theta by itself, what would I do? I would divide by 2, or you can think about it as multiplying by a half, whichever one you want to do. Which would give me what? What is 1/2 times 1/3? Pi thirds? Pi over 6. 1/2 times 2 pi k? Pi k. Same thing here. Take half of it. Get rid of that 2. And I will have theta is equal to what? Five pi over 6 plus pi k. In both of those, k is an integer. Reason why we have to do that first is because, sure, I'm going to have the angles pi over 6 and 5 pi over 6. But that's what I would have if k is 0. You guys okay with that? K is 0. If k was 1, what's pi over 6 plus pi? Not 5 pi. 7 pi over 6. What's 5 pi over 6 plus pi? 11 pi over 6. We actually have 4 answers there. So and I'm going to show you another way you could have done this. If you do it this way, where you just leave the 2 theta and work it out for that, you need to do the all solutions first before you do just little pieces. Another way you could have done this, and this is the way I taught it last year, and then I went, no! Is I did it this way. I said, okay, cosine of 2 theta, use my double angle formula.
Pardon the interruption. Teachers, just a reminder to please go over the revised spell schedule with rulers before the end of the period. Thank you.
Oh, this period ends at the regular time. Oh, we'll talk about it more. And then you would have had to get it in terms of sines or all in terms of cosines. And then you would need it to solve. And you always need to remember, if you take the square root, your answer is both positive and negative. Which is why we have all 4 of those. You don't like either of them. Well, then you got to pick one. Which one do you like? Do you hate less? The first one. Wait, oh my God! Yes.
Do all answers for every single problem?
If it has a 2 theta in it. Okay? All right? Yeah, it's a little bit of a pain in the butt. But usually when I ask you a question that has that in it, I'm going to ask for all real numbers anyways. Okay? So you can work it out that way. Questions on that? Just to make sure that we know which direction I went. I went that, where I said k was 0 and 1, because if k was 2, I would be outside of the circle no matter what.
So, it's something like...
You have just one trig ratio. Right? That's the only guy in there. But you've got a double angle or a half angle or something like that. Okay? Because on that other problem, we had a double angle and the other trig ratio. So what I'm trying to get you guys here is an example for every type of problem. Okay? All right. Go ahead. Notice for number 11, what are we dealing with? Degrees. Try to give that one a shot. And I think you pretty much understand, but just in case you haven't figured it out yet, here is our schedule for today. Second block is going to be finishing at the same time as usual. Instead of having flex 1, 2, we are only going to have flex 1. Okay, that will be over at 9:54, so we do get out of that a little bit earlier. And then lunch will go from 10 to 12:05 based upon your standard fourth period class. So it's just the fact that lunch is a little bit less than a half hour early. Okay? Any questions on that? So looking at problem number 4, what would you suggest we do first? This is just saying 4x squared equals 3. How would you solve that? How do I get the x by itself? Divide by 4. Yeah, to factor this guy would not be pretty. So we would have sine squared x equals 3 over 4. Then you would, one more time, square root it. Whoops, that took a little too far there. Square root that, square root that. Meaning I would have sine x is root 3 over 2. Yes.
Is it alright if I did it reverse where I squared everything first and then moved the 4 over?
You squared everything.
Yeah. I squared the 4 sine squared.
You square rooted? Okay, I was like, yes. If you square root, that's fine. But if we think about 4, what's the square root of 4? No. What's negative 2 times negative 2? When you take a square root, you need to remember that plus or minus. That means when I'm looking at all of my answers, I'm going to have an answer in every single quadrant because it's both positive and negative. Okay? When is the sign root 3 over 2? $60 degrees. Because if you're thinking pi over 3, if that's where your 3 is, the angle is the 6. Okay? Then I'm going to put that into each quadrant, where each of those, this piece is 60. So what would that make this angle here? One more time. 120. What would this angle be? 240, because that's 180 plus 60. What would this angle be? 300. So just within my window, I have 60 degrees, 120 degrees, 240 degrees, 300 degrees. Now we can either write this as 60 plus 2 pi k, 120 plus 2 pi k, 240 plus 2 pi k, 300 plus 2 pi k. And that would give you most points, but we need to check, is there an easier way? How can I get from 60 to 120? No, just adding. Add 60. If I add 60, do I get the next one? No. That would be 180. So that doesn't work. How do I get from 60 to 240? Ooh, plus 180. And then plus 180 and plus 180 and plus 180. So I can take those two. Guys, I've got a worksheet up here for your homework. 60 plus 180k. And then it would be 120 plus 180k. Please read the instructions on the homework.